My name is Nur Atra Farha and I will proceed with the introduction. For a problem statement in our project, traditional gravity or hydraulic clarifiers were not an option for biological solids clarification, such as dairy production, because their system could not generate relatively high solid sludge and had poor effluent quality that consistently met permit effluent requirements for sewer discharge, as opposed to DAF, which was the only technology that could meet those performance requirements. For the objective, we have three objectives. The first one is to polish biological treatment effluent, to reduce loading downstream biological treatment system, and the last one is to establish pre-treatment system to meet sewer discharge limits.
Hello, my name is Abdul Aziz and now we want to continue with methodology. Basically, DAF is a typical wastewater treatment method that providing primary clarity for surface water. Basically, there are a few biological treatment methods that are compatible with DAF. For example, activity sludge, extended aeration, and also contact and aerobic reactors. For the process description, DAF is well known as a straightforward method that employs small air bubbles to float and then connected solid particles to the surface of a flotation cell for removal from a wastewater stream. These are typical rectangular DAF system, for example, coagulation chamber, the flotation cell, surface skimmer, bottom skimmer, baffle or chamber for effluent discharge, and lastly, system of air saturation. There are some drawbacks to using a DAF over gravity clarification. For example, more energy intensive, which is DAF use of a high pressure pump to create a white water stream. Second, chemical requirement, which is biological solid separation use of a chemical flocculant, which is polymer. And lastly, more operator intensive, which DAF system contains more mechanical components that need more human control and maintenance. For the design consideration, some fundamental design issues exist for DAF clarifying of biological solids. These are considerably dependent on the type of biological materials being cleared and the necessary effluent quality. For example, the solid loading of a DAF treating anaerobic effluent may differ somewhat from that on an activity sludge system. The typical design consideration for DAF includes flocculation, hydraulic loading, solid loading, and air solid ratio.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shamimi binti Muhammad Sukri. My metric number is AF190113. So I will present about result and discussion. High rate activate sludge system with dissolved air flotation clarifier for dairy processing facilities. So the system was able to supply the required effluent quality as it's shown in table 3.1 below. Despite the fact that the new dairy generate a BOD load up to 5 times the design load. For the advance in DAF design, several advancements in DAF in design have contributed to greater efficiency and usage of the technology for industrial pre-treatment applications such as air saturation white water system.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Hakimi and I will continue this part. In general, the DF design criteria provided in the most widely used environmental engineering. However, the design guidelines are unclear and gives information that does not match to the majority of industrial applications. Furthermore, variations in wastewater characteristics and the implementation of new chemical programs may make designing a DF system difficult. This emphasizes the importance of modifying DF systems before designing them for various industrial applications. Thus, we need to test them to make sure that the design suit that industrial applications.
Assalamualaikum and hi, my name is Muhammad Alif Haikal bin Rizwan and I will proceed for the conclusion. In conclusion, DAF has been used effectively in clear biological particles from a range of aerobic and anaerobic water treatment systems. In general, The systems produce reasonably high solid sludge and extremely good effluent quality, which fulfill permit effluent standards for sewer discharge on a constant basis. This suggests that DAF is a viable alternative to classic gravity or hydraulic clarifier for the clearing of biological materials. Furthermore, gravity clarifying was not an option in any of the cases it provided, and DAF was the only technology capable of meeting the performance criteria for those applications. So that is all from me. Thank you.